Okay, we're on the Part B section of Chapter 3, Section 2. And the first thing we're going to discuss is inequality of whole numbers. Okay, so what we can think of is how numbers occur in the counting process. So 3 is less than 5 because when you count, 3 comes before 5. Okay, so we can picture ordering numbers with a number line. So here's a number line. Okay, and we're only talking about whole numbers, so let's just look at the whole number part 0, 1, 2, and we know there's more down here on this end, but we're not going to worry about that. Okay, so then we take a unit segment and mark off equally spaced points for each consecutive whole number. If a number is on the left of another number, then it's less than that number. So one of the ways you can mark off a number line is to use one of the longs from your virtual manipulatives for the base 10 pieces, and then you can mark off equally spaced units. So what this will show us is that not only do we have a linear model, like how many units it is long, but we also have an area model, which we'll look at when we get to the multiplication. But this is 1 unit high and 10 units long, so the area of this is also 10. So we write inequality. This is the not official, but the correct mathematical symbolic representation. So if I have any two whole numbers, m and n, where m is less than n, okay, that only happens if I could add some number to m and get the bigger number n. Now an inequality can be written in either direction depending on what you're trying to say. So 4 is less than 9. Okay, so this is the less than. This is the greater than sign. So I could write this inequality as 9 is greater than 4. Either one is true. Now, sometimes the inequality can be combined with the equality symbol to mean that one number is less than or equal to, and the other one that some number is greater than or equal to another. Okay, so one of the conditions has to hold, not both of them. It could be less than, or it can be equal to, or it could be greater than or equal to. We modeled addition by combining two sets and then regrouping. There are 3 different models we can look at for subtraction. Now, subtraction, we cannot commute subtraction, and we cannot just use, if I have mixed operations, I can't just use any kind of association as well. Okay. Now the word subtract means to sub, under, tract, draw away from. So to draw away from under. Okay. So we can think of subtraction as the opposite of putting together. Okay, so drawing out or putting together. So because of that, we call subtraction and addition inverse operations because they do the exact same thing, the exact opposite thing. And what we do is we use to define subtraction that relationship in terms of addition. So this is the definition you'll see in your book. For any whole numbers, R and S, so again, you got to tell which numbers you're talking about, so that R is bigger than S. The difference of R minus S, so notice difference, that means subtraction, and also minus, is written R minus S, and the answer is C, some number, such that if I add it back to S, I get R. This number C is called the missing addend. It's the thing that I have to add back to what I'm subtracting to get the answer. Okay, now in a subtraction problem, let's look at one here. 17 minus 5, okay? When we do 17 minus 5, okay, this number is called the subtrahend. And again, I'm writing this with my mouse, so you'll have to forgive my handwriting. Okay. This is the minuend. Now, subtrahend is the number we're going to be taking from, and the minuend, you can think of minute as small, is a smaller number we're going to subtract, and our answer is called a difference. Or we can call it the missing addend. Okay, so I find the answer by saying, what do I have to add to 5 to get 17? Okay. Now, I don't know if you've ever worked in a store where you've operated a register that didn't tell you how much change you were supposed to give back to somebody. Well, I have. Of course, I'm older than most of you guys. So, whenever you would give somebody their change back, you wouldn't actually perform the subtraction. What you would do is say, okay, so 83 cents from $1. Okay, what you would do is you would just reach in your coin and count up. 83, 84, 85, grab a nickel, 90, grab a dime, 100. And that's how you knew how to give them their change. So we have 3 models for the subtraction algorithm. Okay, and once we talk about negative numbers, which is not for another couple of chapters, then we don't have to really require the number we're subtracting to be larger. But if we want to stay within the whole numbers, then and we want it to be closed and get a whole number answer, then we have to require that the subtrahend is greater than or equal to the minuend. So most of the time, and you probably remember this in early grades, you never heard of a negative number, so because they made the problem so that the subtrahend, the thing you're subtracting from, is larger than the minuend. So these 3 concepts of subtraction are called the takeaway concept, a comparison concept, and the missing addend concept. So we'll illustrate these 3 with the same problem. Okay, so suppose you have 12 stamps and you give 7 away. So by giving 7 away, you're taking out from under the 12 you had. How many stamps would you have left? So we model this by, here's our 12 stamps, and then we take the 7 and we show that we're giving them away by circling it and taking it out. And what do we have left? The 5. Okay, so this figure illustrates 12 minus 7 by showing 7 objects have been taken from a total of 12. Okay, again, 12 is the subtrahend. So we illustrate the subtrahend first. Then we take away the minuend, which is here. And what is left over is our difference. So sometimes the way the problem is stated indicates what kind of concept you might use for that problem. So here's one with a comparison. Notice the wording is a little bit different. So suppose you have 12 stamps and someone else has 7 stamps. How many more stamps do you have than the other person? Okay, so you're comparing the number of stamps each person has. So what we do is we illustrate the 12 stamps for one person and the 7 stamps for the other person, and we compare what's the same. Okay, what is not the same is the difference. So we have 7 stamps in common, and then we have 5 left over, so there's 5 more in the first set. So you have 5 more than the other person. The missing addend concept. Okay, so when we're trying to find the addend, we're trying to find what number do I have to add back to my number to get the larger number. Okay, so notice the way this one's worded. Suppose you have 7 stamps and you need to mail 12 letters. You only have 7 to start out with, but you need to get to 12. How many more stamps are needed? So what do you have to add to get to the 12? So we illustrate here the minuend, the smaller number, okay? And then we see, what do we have to add to get to 12? Well, I'm going to have to add 5 more. So what I have to add here is the difference. Okay, so it's just another way of talking about subtraction. So this figure shows that 5 stamps should be added to 7 stamps to form a collection of 12 stamps. Now if we're going to do an algorithm where we don't actually draw the picture but we do a step-by-step calculation, okay, there are 2 types of examples to consider. Okay, and one is examples where you have to borrow, where you're going to have to regroup in order to perform the subtraction, and those where you don't have to. So here's one where we're going to use, instead of base 10 blocks, we'll use bundle of sticks method. Okay, and this is an example from your book, okay, to illustrate what you have to do when you're regrouping. Okay, so we're going to have 53, right? So we have 5 bundles and 3 sticks. Now what I want to do is take away 29. So 53, take away 9. Okay, so what I've got to do is unbundle. Okay, regroup one bundle, so we got to unbundle it so we have enough sticks to take away. So I'll take one of these bundles and set it all out. Now I can take away 29. I can take away 9 sticks and 20 sticks. So I'll take away 20 and I'll take away 9. Okay, so we had to unbundle one of those bundles, so now I only have 4 bundles left, and I put 10 over here. Then I took away the 9 from the 13 individual ones I have. Then I put the 4 up here to indicate that I took one of those groups